So what we are supposed to do today is to start with alkenes. Alkenes, as I've told you before, is our organic compounds or hydrocarbons that contain at least one double bond. So if any organic compounds contains at least one double bond or one triple bond, we call them unsaturated hydrocarbons. So starting with alkenes, they're actually unsaturated hydrocarbons. The carbon atoms have the capability of forming double bonds, and this is an entirely different homologous series than alkanes. We define homologous series by four methods. Right on your exactly on your left-hand side, you would see that homologous series have the same general formula or the similar chemical properties, or they show a gradual increase in their physical properties such as melting or boiling points. Also, for a homologous series, we also mark that they have the same functional group. In case of alkenes, coming back to their key definition, alkenes are actually unsaturated hydrocarbon because their functional group, their specific thing in their structure is the carbon-carbon double bond, which is found somewhere in the chain. Somewhere means it can be at the start of the chain, in the center of the chain, or at any end of the chain. It can be anywhere in the structure, all right? If there is even one double bond in the entire structure, the structure will not be an alkane anymore or will not be saturated anymore. It will be an unsaturated structure and will be considered in as alkenes. Alkenes, however, may have more than one double bond. Means they might have two, they can have three, they can have more. But in this case, in your case, what we are going to do is that at the level of IGCSE, considering alkenes that have more than one double bond are usually beyond the requirement of our syllabus. So we will only be handling with alkenes that have only a single, only one double bond in their entire structure. All right. The general formula is CnH2n. Remember, the general formula for alkene was CnH2n plus 2. In this case, as there is double bond, so it has two hydrogen atoms less than alkanes, their corresponding alkanes. So they have the general formula of CnH2n, which means in case of alkenes, the number of hydrogen atoms would be exactly double the number of carbon atoms. So as soon as you see a formula, you would know whether it's an alkene or it's an alkane. All right. So alkenes have the general formula CnH2n, where n is the number of carbon atoms. Molecules are unsaturated because we can break this double bond and add extra atoms to the molecule. The simplest alkenes must contain two carbon atoms because at least for one double bond, two carbon atoms are needed. So the simplest alkene starts with ethene, not with methene. Methene cannot exist because for a double bond is in between two carbon atoms, so there cannot be a structure like methene. It does not exist. We start from ethene. Ethene is something that we have said back in chapter number 9. We have studied back in chapter number 3, ethene structure. This is something, this might be a familiar ball and stick model that you might have done with your own hands in previous classes. Then following the basic chains, after ethene, we have propene, a hydrocarbon which has 3 carbon atoms, 6 hydrogen atoms in this case, and 1 double bond in their structure. Following with propene, we then have butene with 4 carbon atoms. So I think you may understand that the series follows on in the same way. 2 carbon atoms, eth, and double bond ene. So ethene, 3 carbon atoms, prop, a double bond represented by ene, so propene. And in the same way, in the similar method, 4 carbon atoms are represented by but. However, a double bond is represented by ene, E-N-E, hence butene. The list would go on: pentene, hexene, heptene, so on and so forth. I hope that's clear. If anyone has a question, please ask. Any questions, students, before I move on? All right, moving on. Let's go through their physical properties. Take a look at this table. Ethene, propene, butene, pentene goes on in the same way. And then we have number of carbon atoms increasing down the series, so is boiling point. In the same way, this arrow shows that the boiling point increases down the group. Here you're supposed to write boiling point increasing. Please write down on your books melting point and density, because melting point, boiling point, and density, all these three properties increase down the homologous series. Please make sure you write it over here. This is table 10.2, and you can go through the page number. This is actually page number 258 we are at. The physical state at room temperature. Now, as you can see, the first three alkenes, ethene, propene, and butene, are gases. And moving on, pentene is a liquid. As we discussed and studied about alkenes, the similar pattern is followed in alkenes. The first few alkenes are gases, next few of them would be liquids, and the ones after that would be solids. The same way as we studied with alkenes, that in case of hydrocarbons, the first few are gases and they are liquids. The liquids might be of two types, less dense or more dense, or less viscous or more viscous. And then there are solids, and the solids are also of two types. The first few solids are waxy solids, somewhat soft solids, and the ones after that, the ones with the biggest structures or the ones with the highest molecular masses are the ones that are the hard solids. So gases, thin liquids, or less dense liquids, then moving on to a more density or thick liquids, then moving on to soft solids, and finally moving on to hard solids. So in the same way, alkenes also change their physical state at room temperatures with respect to their structures. Bigger the structure, chances are that it would be a solid. Smaller the structure, chances are that it would be a gas at room temperature. I hope you get the point. Are we all on the same page? Class, can you hear me?
Yes, sir.
Okay, good.
Yes, sir.
Fine. Moving on. Alkenes are similar to other hydrocarbons when they're burned. So as soon as we start talking about the chemical reaction, the combustion or the burning reaction would be very similar to alkenes. Alkenes will burn in the same way. If the air supply or oxygen supply is sufficient, they're going to burn in that oxygen to produce carbon dioxide and water. And again, in the same way, the equations will be same. However, the balancing would be different. Now, let me tell you, the formula, the XY formula for the balancing of alkenes is only used in alkanes and is only used with complete combustion of alkanes. That formula is not applicable to incomplete combustion of alkanes or any kind of combustions for any other hydrocarbons. All right, that formula is only usable for alkanes and only for their complete combustion. Right? So for incomplete combustion of alkanes, you'll need to process it yourselves, balance it yourselves. Once again, in the case of alkenes, you're going to balance it yourselves. But the products are very much similar because it's a reaction with oxygen producing carbon dioxide and water. So we get help over here. The only thing we need to do ourselves is to balance the equation because the products are going to be same every time. Do not forget, this is when the air supply is sufficient, and this is actually complete combustion. You might have a question that is incomplete combustion also happening in alkenes? Yes, that's true. Whenever the air supply is not sufficient, or we can say it's limited, only then the incomplete combustion will occur. No matter whether it's reacting with an alkane or an alkene, the incomplete combustion occurs with the same products, which means when an alkene reacts with a limited supply of oxygen or air, it produces carbon monoxide and water. The equation is not written over here, but I would suggest, I would recommend writing the same thing on your book over here. Please note down that alkenes also give this reaction similar to alkanes in terms of limited air supply, producing carbon monoxide and water. Take a few seconds, make sure you make a note over here in the book.
Sir, repeat कर दें.
Alkenes in limited supply of air will react in the same way as alkanes and will produce carbon monoxide and water. Alkenes. Alkenes in limited supply, air supply will react in the same way as alkanes, producing carbon monoxide and water. Are we clear? Did you note it down? If you want me to repeat it, let me know. All right, I hope you have noted it down. Moving forward, the presence of carbon-carbon double bond in alkene molecules make alkenes much more reactive than alkanes. Alkanes only consist of carbon-carbon single bonds. Alkene having a double bond will make it more reactive. How? This is another type of reaction that we are going to study. I hope you remember from yesterday that alkanes were only going with two types of reactions. One of them is combustion, we just discussed, and the other one was substitution. We could substitute the hydrogen atoms of alkanes with other atoms such as halogens. However, in case of alkenes, having a double bond gives them other kinds of reactions. We are going to discuss one of those kinds. Other atoms can be added to alkene molecules on exactly the place wherever the double bond lies. The double bond breaks open, the difference produces a simple test for unsaturation, and it can be used in that way. If it is for the presence of carbon-carbon double bond in an alkene molecule, which gives the homologous series its characteristic properties. For this reason, carbon-carbon double bond is known as the functional group. We have discussed functional group before, so we're not going to discuss functional group now. We're simply going to jump to the next heading, chemical test for unsaturation, which means if we have an alkene in front of us, we cannot differentiate between them on the basis of our naked eye observation, because alkanes in the form of gases and alkenes in the form of gases are pretty much similar to one another. However, if we talk about liquids and solids, with a minor difference, they're also close to one another in case of naked eye observation. So if I put an alkane in front of you and an alkene, you won't be able to judge it on the basis of naked eye observation. Hence, what do we need? We need a test to finalize which one of them is alkane and which one of them is alkene. For example, if I put ethane and ethene in front of you, you won't be able to differentiate between both. Both are gases, both are colorless, both are odorless, both are organic, and both react in the same way. So you need a test in order to differentiate between both. And it's not just about ethane or ethene. Propane and propene, butane and butene will behave in the same way. So अगर मैं कोई भी एक alkane और उसका counterpart उससे बिल्कुल मिलता जुलता alkene आपके सामने रखूं, naked eye observation पे आप उसे judge नहीं कर सकते. Probably दोनों colorless होंगे, probably दोनों odorless होंगे, उनके अंदर से कोई odor नहीं होगा, ठीक है, कोई ऐसी smell नहीं आएगी, और उन दोनों का state of matter, physical state, कोई except specific temperature पे भी same होगा. So आपको कैसे फर्क पता चलेगा? So हमें किसी एक ऐसे टेस्ट की जरूरत है जिससे naked eye observation से भी हमें difference पता चल जाए. There are two tests for unsaturation in your book. We call them tests for unsaturation because these tests will result positively with unsaturated compound, I mean alkenes, and negatively with saturated compounds, I mean alkanes. Okay? Let's go with first test. If an alkene such as ethene is shaken with a solution of bromine in water, which is commonly known as bromine water, okay, the bromine loses its color. Let me tell you, bromine has an orange-brown color, just like given in the diagram. Okay? When an alkene reacts with it, it decolorizes it. The orange-brown appearance is lost. is converted into a colorless or a transparent appearance. However, if an alkane is added, alkane does not react with bromine water and there is no change in color. So bromine water का original color क्या होता है? Orange brown. अल्केन इसके साथ रिएक्ट नहीं करता, कोई कलर चेंज नहीं आता. अल्कीन उसके साथ फौरन रिएक्ट करेगा और उसे डीकलराइज करके कलरलेस कर लेगा, and you will instantly, in a matter of seconds, will be able to differentiate between an alkane and an alkene. If anybody doesn't understand this point so far, let me know. Okay, there are a few more things that we need to understand about this test. One, how the test is carried out. Secondly, what would be the equation for this test? So let's go through it. As you can see the figure in front of you, this is a test for unsaturation, and bromine water is tested with an alkane in part A of the figure and with an alkene in part B of the figure. What do? We take the alkane or the alkene, we take a little bit of a small amount of bromine water, and then we shake it with bromine water. The bromine water is decolorized by alkene as shown in the P part of the diagram. However, in A part of the diagram, it is shown that it does not react with alkane and there is no decolorization for alkane. This is how we do the test. When it comes to the point, what is the chemical reaction behind the test? Let's take a look. The chemical reaction behind the test is this. Ethene with the formula of C2H4 simply reacts with bromine in aqueous form, bromine water or bromine solution, which has an orange-brown color. As soon as they react, they form a compound C2H4Br2, which has the name 1,2-dibromoethane. You're supposed to memorize this equation as well as the names and colors of the compounds. Also make sure that you understand their physical states as well. So ethene is a gas. Bromine is used in the form of an aqueous solution, hence aqueous. However, they form a liquid which is colorless, which is 1,2-dibromoethane. Are we clear? Now, in order to understand the extended chemistry behind it, let's understand a few lines. The double bond in ethene breaks open and forms new bonds to bromine atoms, and this reaction will give a single product where a double bond breaks and two new atoms are added to it. Hence, it's known as an addition reaction. Two reactants combine to form a single product. An alkene will not give the same reaction. This two solution will stay orange-brown. However, an alkene will go with this addition reaction. Two substances add together to form a single product, and single colorless product actually. Do we have any questions from this part? All right. In order to explain this last paragraph that I just read a little bit more, what I'm going to do is that I'm going to draw these structures out for you, and I'm going to then clarify how we do it. So I'm going to stop sharing over here, and we're going to use a whiteboard. Just a minute. Okay, class. Let me tell you that the formula for alkene is C2H4. Now, in order to properly understand this formula, we need to draw the structure of alkene. Alkene is actually a carbon-carbon double bond in which every carbon is connected to two hydrogen atoms. Please make sure that you mute your mics. You only unmute them if you have a question. Zainab, your mic is unmuted without purpose. So I was saying that every carbon atom is bonded to two hydrogen atoms and is also doubly bonded with the other carbon atom, as you can see in this structure. Now, when we react it with bromine, bromine is actually Br2, which is also a covalent compound in which one bromine is singly bonded to another bromine. Now, this bromine can easily react with this compound. How? The double bond will break. Only one part of this bond will break, which I'm showing you by a curved cut. And also this bond will break. Okay. One bromine will get attached to one carbon atom. The other bromine will get attached to the other carbon atom. And it would give us the structure like this, carbon. Now there isn't a double bond anymore. It's just a single bond because one of the bonds broke. Now, there were two hydrogen atoms with each carbon atom. So first hydrogen atom with one carbon atom and the second hydrogen atom with one carbon atom. As I've explained that one of the bromine atoms will attach to one carbon atom. So let's draw this bromine over here, right? So this is the bromine over here. Talking about the other carbon atom, the second carbon atom will also have two hydrogen atoms attached to it, which was the previous part of the structure, like over here. And the second bromine atom will get attached to the second carbon atom, making the structure like this, right? So, taking a look at this structure, can you find out the straight longest carbon chain? Of course, there are only two carbon atoms, so this is the straight longest carbon chain. Okay. How are we going to name the structure? Numbering any of the carbon as 1 or 2 or 1 or 2 won't matter. So number any of them in the way that there is one carbon atom, then there is another one. Now, every carbon atom has one bromine attached to it. So there is one bromine attached to first carbon atom and then another bromine is attached to second carbon atom. So there are two bromines, hence 2 di stands for 2, bromo for bromine, eth for two carbon atoms, and ane for singly bonded. Hence the name dibromoethane, 1,2-dibromoethane. This is the compound that is formed. Now the last paragraph was trying to tell us one thing, that the double bond breaks open and there are two atoms. Each atom is attached to one carbon atom individually, which gives us a saturated structure after, which is a halogenated alkane. So take a look. An alkene is reacting with a bromine-based molecule. Two molecules are reacting with one another, and they can give us only one single product. Hence, this reaction is known as addition reaction, in which one molecule can be added to a doubly bonded compound exactly at the place where double bond lies. The double bond breaks open and gives us a single saturated or a halogenated alkane as a product. Any of you who cannot understand anything what I've drawn on this page or explained, please ask. Because this is a very important equation and has been a part of past papers ever since. Any questions, anyone?
सर हमने जैसे नाम कैसे लिखते हैं वो तो नहीं याद करना ना.
इसका नाम आप याद रखेंगे और कैसे लिखने का तरीका मैंने पहले भी बताया हुआ है, so I don't think that should be a problem. मैंने आपको नंबरिंग करना भी बताया हुआ है, स्ट्रेट लॉन्गेस्ट चेन निकालना भी बताया हुआ है. ब्रोमीन को हम ब्रोमो लिखते हैं, स्ट्रक्चर से पहले लिखते हैं, मींस वी यूज इट एज अ प्रीफिक्स नॉट एज अ सफिक्स. अगर दो ब्रोमीन है तो डाई, तीन है तो ट्राई, चार है तो टेट्रा, इस तरह से. ये सारा कुछ मैं पहले एक्सप्लेन कर चुका हूँ. हेलोजेनेटेड एल्केन्स का पूरा नॉमेनक्लेचर पढ़ना आपके सिलेबस में नहीं है शामिल, लेकिन हेलोजेनेटेड एल्केन्स में से कुछ नाम ऐसे हैं जो आपने याद रखने हैं. मसलन कल वाले पोर्शन में हमने 4 नेम्स किए थे हेलोजेनेटेड एल्केन्स के लिए, ठीक है. क्लोरोमीथेन, डाइक्लोरोमीथेन, ट्राइक्लोरोमीथेन और टेट्राक्लोरोमीथेन. इसके अलावा हमने 5th स्ट्रक्चर किया था हेलोथेन. मैं आज आपको 6th हेलोजेनेटेड एल्केन करा रहा हूँ जो कि है 1,2-dibromoethane. These all 6 structures are a part of your course and you're supposed to, you can either cram their names or you can memorize their names or you can go with the strategy that I've just explained to you. So whichever way you're going to memorize it, you are supposed to memorize it. Pick a method, then try to memorize it. Clear, Ayan?
Yes sir.
Good. Any other questions, class? If you have questions, please ask. If you don't have any questions, then I'll start with mine.
सर 1 और 2 दोनों क्यों लिखे हैं?
Very good question, Shazib. One पहले bromine के लिए लिखा है because there is one bromine on the first carbon atom, and we have written 2 because there is another bromine on another carbon atom. So if there were 3 bromine, we would have written 3 numbers. If there were 10 bromine in the structure, we would have written 10 numbers. As many functional groups as there are in the structure, as many numbers are written in the name. Because bromine here is the functional group. Because of bromine, the structure will have different specific properties. Like yesterday, I told you halogenated alkanes have 3 specific properties. 1, they are good organic solvents. 2, they can be used as anesthetics. 3, they can be used as dry cleaning agents. So having a bromine in their structure makes them feasible to these properties, and bromine hence is the functional group. And as many functional groups as there are in a structure, as many numbers are used to name that structure as per the rules of nomenclature. Are we clear, Shazib?
Yes, sir.
Good. Any other questions? Before I start with mine, because I am planning to ask you a few questions just to make sure that you have understood this whole reaction. Because this is just the start of addition reactions. We are supposed to do many addition reactions, not just this one. This is just the start to explain it to you. Okay, so I hope you understand that. Then let me start questioning. Is Rafe here? I guess Rafe is here, but his mic is not working. Rafe, your mic isn't working, right? Okay, no, we need someone whose mic is working. What about Vase? Vase, are you here?
Yes, sir.
Okay, Vase. Then I'm going to ask a question from you. Rafe बच गया, Rafe का mic काम नहीं कर रहा. Vase दुआ करो काश मेरा mic भी ना काम करता तो मुझसे भी question ना होते. Anyway, Vase, let's get started. Vase, let's suppose instead of ethene हम example लेते हैं propene के लिए. ठीक है? तो उसके साथ भी एक
Yes.
मॉलिक्यूल रिएक्ट करेगा, लेकिन प्रोपीन के स्ट्रक्चर में 2 कार्बन तो ऐसे होंगे जो डबली बॉन्डेड होंगे और जो तीसरा कार्बन होगा वो सिंगली बॉन्डेड होगा. तो ब्रोमीन के दोनों एटम्स कौन से कार्बन एटम्स पे जाने चाहिए, डबली बॉन्डेड पे या सिंगली बॉन्डेड और डबली बॉन्डेड पे? क्वेश्चन समझ आया?
Yes, sir. आगे सर. सर डबली बॉन्डेड भी जाएंगे सर
दोनों डबली बॉन्डेड पे जाएंगे. और आपके कहने का ये मतलब है वैसे कि जो सिंगली बॉन्डेड कार्बन है स्ट्रक्चर का उस पर कोई फर्क नहीं पड़ेगा रिएक्शन से, राइट?
Yes, sir.
Very good. Very good. Good answer. Anyone having a different answer? Because Vasa is correct, but if you have a different perception, let's discuss it because I need to correct you then. Anyone having a different perception than Vasa? Okay, good. Now, you need to understand that Vasa answered the question in such a way because the addition reaction only happens with the double bond. Let's suppose there is a structure of 6 carbon atoms, out of which only 2 are doubly bonded and the rest are singly bonded. Then this bromine molecule will only bring a difference to the doubly bonded carbon atoms. It won't be able to bring a difference to the singly bonded part of the structure, which means addition reactions only affect the doubly bonded part of the molecule. And Vase was very much correct when he said that the singly bonded part of the molecule, there won't be any change to it because of the addition reaction. Are we all clear? Are we all on the same page? Boys, do you understand that? What I just said, what I just asked from Vase?
Yes, sir.
And what about girls? Are there any girls in the class?
Yes, sir.
Okay. कौन yes कह रहे हैं? Name please. Who's that? Zuha or Zainab?
Zoha. Zoha.
Zuha beta. Okay, Zuha beta. So my next question is to you. Zuha, वासे वाले क्वेश्चन को कंटिन्यू रखते हैं. You are presented with propene. You reacted propene with one molecule of bromine. And what would be the name of the product? Try to imagine it and try to give us a good guess of the answer.
Sir, can you please repeat the question?
You are presented with propene. Propene is reacted with a molecule of bromine. If ethene reacts with a molecule of bromine, the name of the product is 1,2-dibromoethane. What would be the name of the product if propene reacts with bromine? Zoha, you may take your time. आप ऐसा कर सकते हैं कि अपनी कॉपी पे सामने स्ट्रक्चर को लिखें या नाम को खुद से लिखें और फिर हमें बताएं. Take a couple of minutes and then answer the question. ठीक है? And I'm going to answer the same question from Shahzeb and Ayan. Shahzeb and Ayan, you may use your copies, you may use your imagination, then come up with an answer. Tell me, what would be the name of product if propene reacts with one molecule of bromine? In the same way, in the similar way. Ji, anyone? Anyone among Zoha, Shahzeb and Ayan? Who can
मैंने
answer?
आपको चैट में भेजा है.
I don't. Acha, again. 1,2,3-dibromopropene. If there are two bromine atoms and di stands for 2, why do we have 3 numbers in the chat?
So 1,2-tribromopropane.
1, 2, tri. If there are tri means 3 bromine atoms. A molecule of bromine only contains 2. 1, 2-dibromopropane. Try to write it in the chat. Rafe, why don't you answer the same question? Shahzeb, try to rewrite the name again. This time, try to make sure that you don't make a mistake. Same goes for Ayan, same goes for Zoha, same goes for Rafe. And try to write it in open chat, everyone chat. Don't write it privately. Okay, till the time Ayan, Rafe, Zoha, Shahzeb, they're writing these, I'm going to ask another question from Tanisha. Tanisha, your turn, beta. Kabir, why don't you also write the name in chat? Go ahead, answer the same question. Tanisha, can you hear me, beta?
Yes, sir.
Tanisha, can butane, B-U-T-A-N-E, can butane react with bromine? Please think about your answer, and when you are ready, let me know. Till then, I'm going to ask a question from Zain. Zain, can you hear me?
Yes, sir.
Zain, did you hear the question I asked from Tanisha? What if I ask you the same question? Can butane, B-U-T-A-N-E, I mean an alkane, react with bromine? Fine, I got the answer from Rafe. I got the same answer from Kabir, Shahzeb, and Ayan. Zoha, I think you have the same answer, but Zoha, you need to focus on your spellings. Take a look. What have you written? Would you like to change it? So far, Rafe, Kabir, Shahzeb, and Ayan, all 4 of you are correct. I'll come back to you. So, Tanisha and Zain, first of all, answers to your questions, please. We don't have enough
Sorry
time.
for not.
Tanisha says it won't react. What about you, Zain?
So 2,3-dibromobutane.
No. You're not supposed to tell me the name of the product. You're simply supposed to tell me yes or no. Well, will butane
So yes,
react?
it will.
It will react. How? What would be the condition, Zain? Okay. Zaim and Tanisha, you are going to answer me tomorrow. What would be the conditions of the reaction? Okay. Tanisha says it won't react. Tanisha, by the way, it will react. You need to tell me the conditions tomorrow. Zaim, you might be correct with the name. मैंने नाम पे ज़्यादा तवज्जो नहीं दी. मैं actually आपसे ये पूछना चाहता हूँ, if it does react, what would be the conditions? So Zaim, tomorrow in the start of the class, you're going to tell me what would be the conditions of the reaction. ठीक है ना? हम सारा कुछ ये वाली चीजें पढ़ चुके हैं, so I hope you can tell me. As far as Zoha, Rafe, Kabir, Shahzeb, and Ayan are concerned, okay, you are going to tell me that why would this name, how would you justify this name 1,2-dibromopropane for the product? ठीक है, आप कल जब आएंगे आप इस नेम को जस्टिफाई करेंगे, सही. और हमारे पास ज़ैनब रह गई हैं जिनसे मैंने क्वेश्चन नहीं पूछा. मैं कल ज़ैनब से भी क्वेश्चन करूंगा, ठीक है. So all of you have a question to answer tomorrow, ठीक है. For now, let's wind up the class. Shall I go ahead and wind up the class? If you don't have any questions for me.
No, sir.
Okay, class. Take care, students. Allah Hafiz.